Now we have a palm piece, our assembled finger, and the knuckle cross. And you'll see that that is not symmetrical. This goes towards the back of the finger. That way round. That looks, in fact, away from the finger. That is the pitch joint of the knuckle. And when this goes into the palm, that provides the yaw joint. So this allows the finger to move with a yaw action at the knuckle and a pitch action. And it's only held together by the same elastic element, a spring, which opens the finger. That means that in the event of an accidental collision, the knuckle can just pop apart and then go back together afterwards. No permanent damage done. These long tendons are going to pass back through the wrist and attach to servos in the forearm. So, first make sure this is clear. And then you want to try and ensure that these are not twisted. We can then pass the long tendons of the finger down inside this tube, taking care not to twist them. That actually pushes gently into that gap there. You can also now put 12mm pins into here, and these will also help secure the tendon and prevent it from getting twisted. I think we've got a twist there. Yes, we have a twist. And one more over here. And this pin will also serve as the attachment points for the knuckle servos. Okay. So now that tendon will close the finger. And now we need another tendon to reopen it. And that will be actuated by a spring that will be cut to length from this rather long spring. This is 2mm diameter by 0.3mm wire. To work out the length of that spring, we assemble everything. tendon for the extension attaches to a pin here, passes back through here onto a spring, which is then attached to a pin up here. I'm actually having to drill some holes for this, because previously I used elastic bands which used to wrap around this corner, and now I'm using springs which are much better mechanically. But I haven't got the holes in the right places for them. And I will add these and then update the STL files for using metal springs. Make an estimate. It's about 30 centimeters of tendon. A little over 30 centimeters. Make that into a loop. That passes through there, passes through the upper clearing. Use a screwdriver to make sure this is clear. Pass that loop up here. And now I'm going to need 2 more pins. One here. And one just started here. Again, make sure it's not pinched. And with everything in position, those are the 2 tendons. So what we need to work out is where the knot can be such that it doesn't get stuck in this narrow opening. About there. Take a pen. Mark that point. We don't want a knot to be any lower than that. It tends to tie a figure 8. But I'm definitely open to suggestions on better knots. It's quite hard to get the length of this one in the right position. That's what a figure 8 looks like. It looks like a figure 8. Pull up against any kind of narrow tool. Let's see how we did. Yes, that's very good. knot is tight so it becomes small, and then trim off the excess. Now take a length of spring. This is going to end up with about a 30mm spring. So we can cut off more than 30 to get started. It's a bit easier to work with. So I say 40. This then needs to be made into a simple loop or hook to catch the knotted tendon. Like so. And then pass the spring back through the palm, and we can start to estimate how much tension there needs for it to be the right length. What you want, so when the finger is bouncing at rest, for a light bounce it barely moves at all. For a big bounce it recovers. For flexing the finger it recovers. So it appears to be about here. You can just use a nail to put into a roughly right position. Keep iterating that out. You get to the tension you want. So it's this one here. That will be there. So trim off a couple of loops past it. And then we're going to make another loop here, just big enough to fit over a 2mm pin. So just grab hold of a spring and unwind it a bit. Although this is a bit of a faff, I do still prefer it to elastic bands. Springs have a much better characteristic, and the real problem with latex, so like a balloon, once it goes past a certain point, it suddenly gets much weaker. The springs have a linear extension. So the characteristic of the finger is better with springs. We need to make ourselves a loop like this on the end. For reference, this spring has ended up about 25mm long. And the way to pull these through, Let's get a spare bit of tendon, pass it through that loop. In this case, we can just pass it backwards through here. We can check again. When that's in position, it'll be there. About there. So that's too loose. That's okay. So now I just have to secure this end with a pin. So of course everything's getting messed around because nothing's holding this together at the moment. There's the pin we want to use. To make sure there's enough of a gap to pull the wire over it. There's some other fingers, so it's a tiny bit looser. So now we can start to see how the final shape will be. Everything's a bit loose, I'm going to redo that one. But that is how the springs are added to the fingers.